Hello, today we will do a GROMAX tutorial for protein ligand complex. One thing you should remember that when the protein is bound to certain ligand, for its MD simulation, we have to separately prepare the topological file for these things and for the complex, and then we have to run it. So it's a very basic tutorial which we will do on this lysozyme, that is the T4 lysozyme protein, and we will download it and we will prepare it. So according to this tutorial, if we look at that, that's like this, that we are doing the things on lysozyme. So here in this tutorial, you can see that we are going to work on this T4 lysozyme protein with the PDB IT3HTB. So one way is to prepare the protein is to use these grep commands. The other way is use either of these programs, which includes VMD, Chimera, Pymol, and then we need to work on that because we don't need the crystal waters, we don't need the ligands which are not intended. So one way of doing is that you use this grep command. The other thing is, why not we use the pymol? So here I will tell you that we can use the pymol for that purpose. And pymol is very easy to use. I think in last tutorials we have discussed that how we can use the pymol program to prepare the protein, to remove all the waters which are present inside, and also how to remove the unintended ligands. So get PDB, and then I will just type the code which is of the PDB, and I will say it, okay, download it for me. So this is one way that how you can download it. Protein will be here, 3HTB. So let me check, this was the protein. Yeah, this is 3HTB. Other way, you can go here, you can download it here, and then you will download legacy PDB format. Okay. Otherwise, Pymol direct opening is totally fine. Here you can see we got multiple things here. We got these red waters and we got these ligands which are attached here. And we got somewhere this species and this species. What are these? Let's dig it up. So these species, these are present. So here let's prepare our protein. Here you can see the zeros. These are all the water molecules. And our chain B is PO4, PO4. And then we got here JZ4 and BME. We don't need these ligands actually. One way of doing is that we will just right click on that and we will remove it. And so as the water. The other way of doing this thing is by usually the command prompt, that you just go to command prompt and you can say remove org and it will remove all of your ligands. So I will just use this particular way. I will right click, I will say remove, because that is the easiest way to remember actually, and I don't need even this BM and I will that. So, but first I need to select it and then I need to remove it. Now we are only here with the water molecules and the ligand which we need, that is the JZ4. What we will do now? We will right click on actions and we will remove all the water molecules. So you can see that we don't have now the water molecules which are present here. Next thing is to separate the ligand from the proteins. Okay, so I will click on the ligand. So this is called now selection. This is in selection. Here you can see this is highlighted, this selection. I will go to A and then I will say it copy to object or extract object. I will say copy to object. Okay, so I will press copy to object. Here is the object which is present here, object 1. Okay, I can rename it if I want it. So I can rename it to ligand here. So that's my ligand. and this is the protein. So I will just name it as actually the protein to be very precise. So we'll do everything very clearly. So we don't need actually in protein this ligand. Here you can see that we got these two things, the protein without the ligand, and here we got the ligand. Now we can save them separately in certain folder actually. So here you can see the protein, you can examine it. This is totally clean protein. You will go to file, you will go to export structure, export molecule, selection is fine, and then you can save it anywhere. For example, I'm for now I'm gonna save it here by making a new folder on my desktop. I will say it ligand underscore T, and I will open it here. You need to select PDB and you need to save it. So our protein is saved now, but I need to give it name. Okay, I will give it name as protein.pdb. I have saved. Now I need to save the ligand molecules actually. So this is our ligand molecule, which we have just copied or extracted. And we will export the structure. We will export the, and then I will say it ligand. Don't forget to change CAF to PDB. There are a lot of options here, you know. You can save it in any format depending on what you want to do. I need PDB, I will save it in form of PDB. So these two things, they have been saved actually in the different formats. So we don't need bimol, but let me check that either these things are actually present in my folder ligand underscore T. Here you can see that we got these two things separately. This is ligand molecule, and this is, even we can examine it by opening it in our favorite program like Notepad. And here you can see that only ligand molecule is present. There is no waters. There is nothing else is present. I will close it. Even proteins you can examine in the same way that either there is any entry of the ligand. So to be very careful, you can do that actually. And here you can see we just got only the protein, and we got here just the protein atoms, and there is nothing about the ligand which is present here. So I will close it down. So this is how you can prepare the first step for your tutorial, that how you can prepare the protein. Even this tutorial provide you a clean protein. From here you can download it, but we have cleaned it ourselves. Now we got these both things, we got the ligand and we got the proteins. So this is first step to prepare the ligand and proteins. Then we will move to the second step in the next video.